the session and you think that's good, you can see the board, everything I left on there in all its glory from last Friday, right?
You should scooch it over.
Which way? To the
That way?
that way?
There. Yeah.
That
That's
better?
good.
So I did promise the 90% rule. We talked about that, but we got to get something done in class. Otherwise, you might as well just be working on your assignments. So 210 is due tomorrow. I'll see what I can do about getting assignments back. They want to have a test over only chapter 2. I may want to have it over chapter 2 and chapter 3. Chapter 3 has like 5 sections that we cover. So it's more like a half a chapter, but it's a lot of graphing without a graphing calculator. Anyway, stuff like that. But do you have, they apparently they didn't have any questions through 2.9. Are you the same?
What?
Any questions in 2.9?
Yeah.
Okay. What?
I got really confused on number 46 for some reason.
Okay. Is that that's the word problem one?
No, that's 54.
Oh,
46
did you have to do
is
that one too?
huh?
You didn't have to do 54. Did I do that in on the video? No, we had no. You did have to do 50. Yeah, you had to do 54. Okay, but 46. What's your confusion there?
I really don't know. I just got really confused.
What'd you get for the first derivative?
I didn't.
Oh.
Okay, so like I don't know what I did wrong. I did it like 3 times and I still was not getting. I don't know.
You didn't get the first derivative?
I don't know.
We're trying to find dx, right?
Huh?
Or the second derivative of y with respect to x.
Yeah.
Right. So I'm going to take the first derivative first, right?
What?
Yeah, take the first derivative. It's x squared plus y squared is 100.
X squared plus 25 y squared. 25 y squared.
25 y squared. So what's the first thing you do, class? Up or out? Take the derivative with respect to x, right? You just take the derivative with respect to x. Did you do that?
Yeah.
What do you get?
See, okay, but I don't know.
There's no buts. Derivative of x squared. The derivative of the sum is the sum of the derivatives, right?
Yeah.
So the derivative of x squared is
2x.
right, and that's the derivative with respect to x, right? So that's the variable, so it's fine. So we're good there, right? And then plus, well, now we got 25y squared, the derivative of that with respect to x. So we act like it's okay, right? And then what do you get? 50y, right? To the first, just using the power rule and derivative of the function. But then because it was a y, not an x, what do I have to attach? dy dx, by implicit differentiation, right? Really, that's just the chain rule. That's all that is. And then what's it equal though? What do you get on the right side? 0. Derivative of a constant with respect to any variable is always going to be 0. So if I want to know what dy dx is, get everything that's not a dy dx to one side, all the dy dx terms to the other. Factor out a dy dx if there's more than one of them, and then divide. Right? So that's the process there. So what would dy dx be? So you have 50y dy dx equals negative 2x, and then divide both sides by 50y, right? I didn't have to factor out because it's already factored, right? And so what's that? It equals minus x over 25y, right? So that's what dy dx is, correct? Yep. So, but it doesn't want that, it wants the second derivative of y with respect to x. So what do I gotta do to both sides of this? Take the derivative with respect to x again, right? And then what do I gotta do on the right side? Quotient rule, right? And then you're probably gonna end up having to attach a dy dx at least one time in there. And then what do you do with that? I can sub back this thing in for that, right? And then if you happen to have where the original x squared plus 25y squared somewhere in there, you can replace that with 100, right? If it shows up. Does that make sense or not?
Yeah, I got that, but then I wasn't thinking that was the answer. So yeah,
So
I
you
was
did
trying
get
to do
me.
something.
So what'd you get for a final answer?
Well, you're supposed to show that it equals that.
Oh, so it gives you the
I
answer.
was So I got the first derivative, but I was trying to make it so you could like somehow take out the dy dx, and I don't know. I don't know what I was thinking.
That's only that's only like that, like if there's more than one term that has dy dx, we want to factor it out so it's multiplication and then divide what's left on both sides. But we didn't need to do that here. So here, if I take the derivative with respect to both sides, I'll have the derivative on the left side with respect to x is just the second derivative, right?
Mm-hmm.
And the right side is quotient rule, so it's bottom times derivative of the top, derivative of minus x is -1, right? Plus the top minus the top, which is minus x, times derivative of the bottom, which is 25, but then times dy dx, right? Because it was a y there.
Yep.
All over the bottom unsquared.
Mm-hmm.
Wait a minute, 25y quantity squared, right?
There you go.
Anyway, but then I got to plug in what dy dx is, and it's minus x over 25y, and then you got to go through some algebra simplification. Did everybody else kind of get where you got to show out okay? Or you got then you sub it in where? You got to sub it in if you get something that's equivalent to it, yeah. I mean, so if I do this and then plug it in what dy dx is, I'm just going to do that here. Dy dx is minus x over 25y, right? And then I can cancel this 25 with that 25, can I? Everybody agree? And then I can multiply top and bottom by what? I got a y in the denominator, right? Don't I? Still there? So I can multiply top and bottom through by y over y. So minus a minus is plus a plus. So I got minus x squared over y there. But anyway, multiplying that right through there, I get minus 25y squared. Right? And then minus x squared, because the y times the first one is y squared, and then the y's cancel in the second term, right? All over, and that's going to be 625y squared, right? But then what can I do here to make it look like the top one? Factor out a -1. So this ends up, if this equals 100, then this is going to equal what? Minus 100, right? And then you can divide top and bottom by 25, and what do we get? Minus 4 over 25y squared. Does that help?
Yep.
Okay. All right. And then 54, you got that okay? Everybody got that okay? This is the one where I say you got to watch my video because I didn't really go over one like this. You want to do one like it or not? Or do you want to just move on to 210? I got 20 minutes, so it's whatever you want to do. Whatever I can do to make your life easier. I need to, I can talk about 90% rule tomorrow. It is snowing. I've golfed and coached my girls in softball with snow and sleet, so. Fine, football, I guess. Football can play in any weather except apparently lightning is bad, but I don't really remember that day. Yeah. All right, no question, like, all right, so 53 or 54, you're good? Do you want to tell me what your answers are? Was this stuff due today, post 2-9? Or do you want to turn it in tomorrow or what? You can turn it in tomorrow, I don't care. But you could at least tell me what you got for an answer. I can tell you if it's right or wrong. What'd you get for A? What's the label? Negative 11.2? Yep. Not naughty miles, nautical miles per hour. The nautical mile is about 1.2 miles in it, or 1.1 something. So,
How does that mean? You have a negative.
what'd you get, Kylie? On A. You get negative 11.2 on 54?
Yeah.
They're not going away. The distance, that's the distance, right? If the distance is negative 11.2 nautical miles per hour, what does that mean the distance is doing? Decreasing. So you can write it without the minus sign by saying it's decreasing at a rate of 11.2 knots. Okay, approximately. And by the way, I don't really like approximate, but so if you didn't make it approximate, because whatever negative 896 over 80 reduces to. But anyway, what about B? $34.9. Did everybody get that? Okay. Yeah, that's fine. If it doesn't say like what's round to, go nearest 10th. But yeah, nautical miles per hour or knots, right? So how do we talk about that? That's distance dz dt. Hopefully you drew a picture, right? Hopefully you drew pictures. But anyway, dz dt, the distance would be what if it's positive? How do we say that in English, in other words?
Larger.
It's increasing, yeah. The distance is increasing at a rate of approximately 34.9 nautical miles per hour. But so if you didn't get those answers, you need to get those answers. Okay, because those are the answers. But then need to show your work. So I'm not going to go through show the work. I'd be happy to do a different one or another odd or something. But we can go on to 210. So you all watch my videos in 210, right? And also, by the way, don't forget about the book, because the book has some really nice examples. Some I do in my videos. Like I'll go through the example in the book, but otherwise they have it written out. And make sure you follow the steps, step by step. Ooh, baby, Backstreet Boys. I didn't like boys. Who's in that? Ricky Martin. Don't remember him? Living La Vida Loca? You don't know that song? Okay. Let's do, what did I do? How many word problems did I do in the book? Well, let's just do an odd. 210, pick one. 1, 3, 5, or 7. Pick an odd. Did we do one of these yet? I don't think I did. 1, 3, 5, or 7. Pick a number, any number. Hannah. 1, 3, 5, or 7. Pick one. 3. Okay, what does number 3 say? This is section 210. We'll just do it quick. If x over y, no, if x times y equals 20, it says x times y equals 20, and what else does it say? Dx dt equals what? -5? No. Oh, dy dt equals 10. Then find dx dt. Is that right? Oh, dx dx, that's 1. That's easy. Dx dt. So how are we going to do this thing? So this is number 3, section 210.
Also says when x equals 2 at the end.
When x equals 2?
Perfect.
Okay, so if x times y equals 20 and dy dt equals 10, then find dx dt when x equals 2. So what's the first thing we're going to do? Notice the denominator is what? With respect to t. So really, the reality is x is some function of t. X is x of t, y is y of t. There's some function of t, right, in theory, correct? So x could be, you know, t cubed plus 2t minus 3, and y could be cubed root of t. Something like that, whatever. But anyway, so the first thing I'm going to do is what? Take the derivative of both sides with respect to what variable? T. Correct, d dt of both sides. So to do it on the left side, what rule do I need to use? What type of thing we got going on there? It's x times y is a product, so I need to use the product rule, right? So it's going to be the first one times derivative of the second one. So the first one is x. So x times derivative of the second one. Derivative of y with respect to t is what? 1, and then I got to attach a dy dt, right? Or you could just say the derivative of y with respect to t is what? It's the derivative of y with respect to t, dy dt, right? Or you can say 1, and then by the chain rule times dy dt, or by implicit differentiation. Product rule plus the second one, which is y, times the derivative of the first one. What's the derivative of x with respect to t? dx dt. And then equals, what? What does it equal? 0, because the derivative of a constant with respect to any variable is 0, right? So I got this here, so I have that. And then what did we say? We said that dy dt equals 10. So I can drop that in right there, right? So now I've got, so this implies that we've got 10x plus y times dx dt equals 0, right? I'm trying to find dx dt at a certain point in time. So I want to get everything that's not a dx dt to the other side. So this is just algebra, right? So it equals minus 10x, put it on the other side with the opposite sign, right? Everybody get what that is? Just algebra. Divide both sides by y. And what do we get? So dx dt is minus 10x over y, correct?
Yep.
But then it says, find dx dt when x equals 2. So if x equals 2, okay, when x equals 2, what's y? When x equals 2, I can plug in my original. So I've got 2 times y equals 20. Well, 2 times y equals 20. So y equals 10, right? So when x equals 2, y equals 10, and then we're going to plug both of these in right here, right? So dx dt is going to equal minus 20 over 10, which equals minus 2. So my final answer for this one would be minus 2. dx dt equals minus 2 when x equals 2. 2 should be the answer there. Is that what the back of the book says?
Yep.
Then the book is, you're getting good at this game. Look how far you've come in literally 2 months. Like this is almost when like a baby goes from crawling on his belly to walking and running around, right?
So where would we be if we were like in the normal year where like we took a cane? Right now.
probably just started. I don't know if you'd probably be doing some derivative stuff. I don't know. I'd have to look back when my daughters took it with them. You know, the difference is usually first semester you get pretty much through derivatives at a fairly decent level. He doesn't do the theory, right? He doesn't spend nearly as much time on the theory and the limit function. So you're probably being derivatives. You're probably being derivatives there too. But in the second semester, it's anti-derivatives. We're going to do that before you're done. All right. So let's pick what odds did I do in the, like I could do 9, 11, 13, or 21, or 35. And I can't remember which ones I did in the videos.
You did 21 in the video, I know for sure.
That was the cone. Yep. Did I do 13 conical pile or not? Did we did a snowball fight, didn't we? Number 11.
Yes, it was so white.
So I could either do 9 or 13 maybe. Some other ones I haven't tried, but we could do a different one too, so I don't care. Which one do you want?
Try 13.
13, I didn't do that one.
No.
Sand is being dropped at the rate of 10 cubic meters per minute onto a conical pile. Okay, so we're going to draw that. So we're going to draw the sand. So always, when I have a word problem, I want to visualize what's going on, right? So there's my cone of sand, right? I got a radius here, right? But anyway, so I'm dropping, I don't know, I got this machine over here, tractor or whatever, and it's dropping sand on here, right? And it's making a cone. And then what does it say? So I'm going to try and solve this like you, so I haven't done this in a long time anyway. Onto a conical pile. The height of the pile is always twice the base radius. So the height. So here's the height right here. That's h. But the height is always going to be 2 times the base radius. So I did say a cone has to be a circle on the bottom, right? So anyway, the height is 2r. Then what? At what rate is the height increasing when the pile is 8 meters high? So let's just write that out. At what rate is the height increasing when the radius is what? 8 meters?
Yeah.
Radius is 8 meters.
The pile is 8 meters high.
When the height is 8 meters, so the radius would be what?
2 or 4 meters.
So the radius is 4 meters, right? Because it's always going to be double. But at what rate? This is dropping at what rate? How many?
10 meters cubed per minute.
10 cubic meters, which is volume, right, per minute. So what is so what does this represent? Let's get what equals 10 cubic meters per minute? And if you okay, so it's a rate of change, right? So 1 minute later, 10 cubic meters is on there, more. 2 minutes later, 20 cubic meters is on there, right? It's a rate of change, right? Which is a derivative. A derivative is a rate of change, right? So what rate of change is this? Like, tell me what equals 10 cubic meters per minute. If you're not sure, I'll tell you how to figure it out. What's changing at that rate? The volume is changing at that rate with respect to what? Time. Okay, so dV, the change in the volume with respect to time. So dV dt actually equals a positive 10 cubic meters per minute. So you might get confused with the directional. Just because I'm dropping it down on there doesn't mean it's negative. The volume is actually increasing, so it needs to be positive. So the volume is increasing at a rate of 10 cubic meters per minute, right? It's a constant rate of change here. But anyway, what if I didn't know, what if I wasn't sure? Let the labels do the talking. So cubic meters is what? Volume, or, right, is volume, right? So volume, so this is change in volume with respect to, and minutes is time, right? So you can let the labels do the talking here. So dVdt is 10 cubic meters per minute. And then what do we want to know? Do we know what the volume of a cone is? What's volume of cone? 1/3 area of the base times the height, right? So if you have a, here, I kind of think of it this way. If I put a cone on this side and a cone on this side, it's supposed to be the same circle on top, but basically you got a cylinder. So 3 cones make a cylinder. The cylinder you can turn upside down, looks the same. So cylinder is area of the base times the height, right? So there's 3 of them would fit into the cylinder. So it's going to be 1/3 area of the base times the height. So what's the area of the base? It's the area of a circle, pi r squared, right? So it's 1/3 pi r squared times h, right? But what do we know about the height? It's 2r. So the volume of the cone is going to be 1/3 pi times r squared times 2r. So what's that? 2/3 pi r cubed. Everybody agree? If you plug in 2r for h here. Everybody agree? So I want to always, anytime we can put it in terms of one variable, that's good. So then what can I do to both sides here? By the way, before I do any more math work, let's try and figure out what we're trying to answer here. And I got 3 minutes. Please do not leave early today. At what rate is the height increasing? So what am I looking for? Crap, I got to change this. But at what rate is the height increasing? Well, with respect to time. So I'm looking for what variable? dH dt. I want, this is what I want dH dt. So I'm looking for dH dt. So what did I do that I shouldn't have done? I changed it over to the radius, right? So, but should I, instead of doing that, maybe I should put in what R is. R equals H divided by 2, correct? So let's do that instead. So instead of this one, if I want to know what rate the rate is changing, this would have been great. So dr dt, this would have been great. But that's not what I want. I want dH dt. So the volume of the cone is going to be 1/3 pi, and instead of r squared, it's h over 2 quantity squared times h, right? So what's that? That's going to be pi over 12, because 2 squared is 4, right? Pi h cubed. Oh no, I already had pi. Pi 1/12 pi, or pi over 12 times h cubed, correct? And then what can I do to both sides? What do I want to take the derivative with respect to both sides of? So pi over 12 h cubed. I'm going to take the derivative of both sides with respect to t. Okay? Derivative with respect to t. So what's the derivative of d with respect to t? dv dt, right? Which actually was given, it's also positive 10 cubic meters per minute, right? But anyways, dv dt. And on the right, I can just use the power rule, constant times a function, and then the power rule, right? So 3 times pi over 12 is pi over 4, right? H squared. Does everybody agree? Just use the power rule there, drop it down in front. Okay, so then, but then put in what you know. What do we know? dV dt. So we have this. I need to come back and run out of room. So I'm going to put this is dV dt. I'll put it up here and then give myself some room to work here. Hopefully you can see the whole board here, but I'm going to try and get this one finished up. So dV dt is 10. So right here, I'm just going to rewrite this. So 10 cubic meters per minute equals pi over 4 times h squared, right? Oh, no. What? I wasn't done yet. My goodness. This is why you're looking at me funny. I'm wearing the wrong contacts again today. But anyway, what do I got to attach? That was an h. And what was I taking the derivative with respect to? T. So what do I have to attach that I didn't? dH dt, right? So anyway, so times dH dt. I'm trying to solve for dH dt. Now all I got to do is plug in h here, right? And so I got 10 equals pi over 4 times h squared is 64 times dH dt. Solve that for dH dt. This is going to be 16 pi. It should be 10 over 16 pi, which is 5 over 8 pi equals dH dt for this specific example. But dH dt, what's the label? The height is in meters, so it's going to be meters per minute, right? And it's positive, so we can say that the height is increasing at a rate of 5 over 8 pi meters per minute, which should be the answer in the back of the book, and I'll verify that. I'll let you know if it's not. Which one is it? Number 13, yep. Awesome. Okay, so try to have 210 bags, the 29, 210, you can turn them in tomorrow. Thank you. Okay. See you. Thank you. Later. Don't get detention right before Thanksgiving. Yeah, that's fine. Yeah.
Are you open to teaching Calc 3 this summer?
Summer? Maybe. You need it?
Yeah.
For one?
That makes things better to take it now than in college.
It'd be a lot better for you to do it with the like same book. Okay. Are you good or do you want to stick around?
Just gonna say bye.
You want to say bye?
I'll see you later.
All right, sounds good. And you want me to have yours at the front desk so you could have somebody pick it up for you if I bring them in tomorrow? Homework?
Yeah.
Okay. That's my goal. So, all right. See you later.
Okay. Yep. Bye.
Yep, bye. Let me just quit recording this.